meeting. Okay, all right. So the session has started recording. So now that is what. So what is normalization? In the PDF, you will be seeing what is normalization. Here it is written. It is a step-by-step process of splitting the bigger table into smaller table without changing any functionality. See, when we started normalization, when was database invented? Database was invented around 1970 by E.F. Codd. At that time, there was no multiple table concept. Even you have 500, 600 columns in a table, all the columns were put in a single table. If you take any project, it can be banking, it can be insurance, whatever project you take, there was only one table. I am speaking about the age of 1970. But even the new columns come, they were putting into a single table. So what was the issue with this? The performance started degrading. For example, in this normalization table, I have taken a students table. So in a students table, we have student ID, student name, student date of birth, student phone number, and course details. We have course name, course hours, and also the marks. So all these details are there in a single table. So basically, if I want to just put the marks for particular person, for Suhas Basraj Meal Goal, I have to not only add his marks and the grade, I have to again duplicate his name, again his date of birth, his phone number, everything I have to duplicate just to add the marks. This is only few columns. In the real time, you will have 100 columns. Just to insert 2 or 3 columns, we have to add all the columns in a row. So, 1 minute. All right. So that's what. So normalization. What was the issue? Just to add few columns in a table, we have to insert for all the columns in a particular record. So this created lot of redundancy. The impact was something like that. If we start doing like that, you want to take the money from the ATM. If all the data, assume that all the banking domain data was in a single table. There are thousands of table. For example, you take ICICI Bank, there are thousands of table. All the data were merged and kept in a single table. So what would have happened is, if you go to the ATM, insert a card, to put the pin, it would have taken half an hour. Once you put the pin, go to the next page, it would have taken 1 more hour. By the time you get the money from the ATM, it would have taken easily 3 hours if you had kept all the data in a single table. So obviously, keeping all the data in a single table will decrease the performance. The reason is, you want to insert few columns or a few records in a particular row, you have to add all the columns. This is why the performance degraded. So to avoid this or to manage this performance overhead, they started normalization. So what is normalization basically? Normalization means single table would be split into many smaller tables. That is what even we want. We want to break a single bigger table into many smaller table. So to improve the performance, this will improve the performance. So not only we have to split the single bigger table into many smaller table, the table has to be splitted in such a way that it should work. It should not change any functionality. It should not change any functionality means, before breaking the table, how it was working. Exactly after breaking the table also, it has to work in the same way. For example, after breaking the table, your account number should not reflect with some other person's amount. Okay, so that becomes a problem. After breaking the table also, your account number has to be reflected with your amount, your father name, mother and all. So That is the straightforward statement for normalization. Break the table into many smaller table without changing functionality. And again, you cannot simply break the table. I like only student ID, student name, make it one table. I like date of birth, phone number, make it one more table. I like all course ID, course name, marks, grade, make it one table. You cannot divide or break the table however you want. There is some rules which is called as normalization rules to break the table. You have to follow that normalization rule to break the table. That normalization rules are 1NF, 2NF, 3NF, which can be elaborated as first normalization form, second normalization form, third normalization form. You have to know that normalization form and you have to break the table according to that rules. Those are called rules. It's like a Bible. You will understand that rule, you will break the table according to that rule only. You cannot break however you want. So let us see what does first normalization form says that. A first normalization form says that a table is said to be in first normalization if all the values are single value and there are no duplicate records. What does that single value means? See, Suhas, Basraj, Nilgol is not a single value. It is a three-valued record. That means Suhas is one name, Basraj is one more name, Nilgol is one name. It has first name, middle name, last name. Phone number is not one value. It has two values. So it is not a single value. Obviously, first normalization form says that table should be a single value. However, we don't have a data in a column with single value. We have two valued phone number, we have three valued name. So what is the first rule is we have to break into single value. How I break the table? Just see below. I've just broken this table as shown here. Now I have made three value which was there in name. I have split it into student first name Suhas, student middle name Basraj, student last name Nilgol. Now I have phone numbers, phone number 1, phone number 2. So now I have made all the values of the above table to singled value or atomic. But this is not the end of first normalization form. First normalization form also says that there should be no duplicate records. However, if you see this red icon, whatever red font letters, it is not, it is duplicated. So as Basraj Nilgol is duplicated twice. So this again is against the rule of first normalization. We have made off correct of the first normalization. That means we made all the values single value. However, still there is a duplicate records. So how can I remove this duplicate records? Just see the below table. I have splitted one table into two table. I made one table, first table as student table, second table as course table. If you see here, Suhas Basraj Nilgol has not been duplicated over here. So this is the first normalization form. First normalization form says that all the values should be, that is what? First normalization says that all the values should be atomic, which means single value, and there should be no duplicate records. There should be no duplicate records. So we made the name into first name, middle name, last name. So for the single value, and again we removed the duplicacy also, duplicate records. So this is all about first normalization form. Okay. Now just ping me if you have any doubts. Any doubts, you can chat with me. I will not be speaking with you. I will not listen to you. You have to just chat me. Any doubts you have, you can chat me. If you don't have doubts, I'll continue with second normalization, third normalization. No doubts, Karthik. I am clear. Good. How about others? Good. How about Deeps? Any doubt? No doubt. No doubt means I will think that you have understood everything, or I will think you have not understood anything. Is it clear or all clear? It is okay. Okay. Okay, all right. Okay, all right. Let us continue with second normalization form. Any doubts you can ping me in the middle. So let us do the second normalization. Second normalization. Let me continue with the PDF. So second normalization says that a relation is said to be in second normalization if it is already in first normalization and non-key attribute are fully dependent on the key attribute. So this is very important thing which you have to understand. A relationship is said to be in second normalization if it is already in first normalization. What it says is always normalization is sequential in nature. That means you have a table, you can convert to second normalization only if you are giving the first normalization table. It is always sequential. So you cannot directly convert. You cannot directly convert from table to second normalization. You cannot directly do that. It is always sequential in nature. First, one single table has to be converted to first normalization. If you want to convert the table to second normalization, you have to give the first normalization table only. That means the table, if you want to convert to second normalization, you have to give the table which is atomic and free from duplicates. And if you want to convert to third normalization, you have to give the second normalization table only. So that is what the first line says. A relationship is said to be in second normalization if it is already in first normalization. And non-key attribute or fully dependent on key attribute. Here non-key attribute means non-primary key. Non-primary key or primary key, foreign key, we have discussed in constants. Non-primary key are fully dependent on primary key. So non-primary key are fully dependent on primary key means whatever you are seeing this green color, what is primary key basically? A primary key is a unique key which will identify all other members in the table. For example, your college registration number. Giving your college registration number to any administrator or any college person, they can easily find out your name, your phone number, your address, your father name. With the passport number, they can easily find out all of your details. With the voter ID, they can find out all other details. So in the college, your registration number becomes primary key, which will uniquely identify remaining columns in the table. This is what student ID or registration number. Voter ID, we can give it as primary key in the government portal, where using voter ID, I can find out all your details. And also passport number can also become primary key. Using passport number, I can find out all other details. So in this example, student ID or registration number is the primary key. So what it says is non-primary key, second normalization. If you want to convert the table to second normalization, it has to be in this form. That means non-primary key are fully dependent on primary key. That means all this white color or non-primary key should be fully dependent on green color. So let us see. See, going to the college. If you go to the college, give the registration number, they can easily find out your name. They can easily find out your phone number. That means this table is fully dependent. That means all this white color are fully dependent on this green color. That means all this non-primary key, which is white color, is fully dependent on the primary key. This table satisfies the second normalization form. Let me continue with this table. Going to the college. Okay, I will chat with you. Going to the college. I will give you the course ID. Can I easily find out course name and course hours? You guys have to tell me. I will repeat the question again. Going to the college, you give the course ID. Can you get course name and course hours from the college librarian? Yes or no? Yes, good. How about Deepti? Yes or no? You go to the college librarian, You give the course ID. Can they give the course name? Can they give how many hours? Yes, of course. So let me continue in the same way. I'll go to the college, give the course ID and ask for marks. Will I get? Example, yeah, let me help you out. I will go to the college and ask and tell DBMS and ask for marks. No, obviously no. Good. So obviously, yeah, good answer. They won't be knowing. Yes, yes. So obviously you go to the college and tell DBMS marks. He will go mad. Straightforward question by a lecturer or any person, concerned person is, boss, for which person you are asking the DBMS mark, or you go to the college and give the course ID, for which person you are asking the marks. That means course ID is dependent but partially dependent in getting the marks. To get the course, to get the marks, you not only require course ID, you also require student ID. That means student ID plus course ID will give you the marks. And also the second normalization says that all the non-primary key are fully dependent on primary key. That means all this white color should be fully dependent on primary key, that is course ID. But however, if you see the result mark is dependent on course ID, but result mark is dependent on only on course ID. It is partial. It has partial dependency. But partial dependency cannot be there in second normalization form. Second normalization directly says the rule, all the non-primary keys should be fully dependent. To make it fully dependent, you should have student ID and course ID as primary key. That means this is not satisfying the second normalization rule. So what I will do is I'll again break the table and make it to the three tables. So if you see the second normalization, three tables have become. One is student table, which does not have any issue because student name and phone number can be easily identified by student ID. And next I have broken the table. I have made one table as course table, which is however not written on the top table name. With the course ID, I can easily find out course name and course hours. Next is marks can be easily find out if we make student ID and course ID as a primary key. Again, grades also we can get with this. Means student ID and course ID I have made as primary key. So one more important point here is if you have more than one primary key in a table, then we call it as what kind of primary key? Any idea for you guys? If we have more than one table, more than one column, that is what I have written. If you have more than one primary key in a table, a better way is if you have more than one column as the primary key in the table, then we call it as, no, wrong. Then we call it as, okay. Anyone? Why? Okay. No. No. Okay. Foreign key. Okay, so we call it as composite. Composite means many. If we have more than one column as primary key, we call it as composite primary key. Good question for the interview. So here we have two columns, that is student ID and course ID as the primary key. So this is a composite primary key. Obviously a marks table as composite primary key. Now do you guys agree? Second normalization. These three tables are in second normalization. All the columns are completely fully dependent on student ID in the student table. Course name and course hour are fully dependent on course ID. And if you come above this third table also, marks and grades are fully dependent on student ID and course ID. Do you guys agree, everyone? Any doubt? Okay, now let me continue with third normalization. See, let me quickly repeat if you have not forgotten. So first normalization says that, what is normalization? Basically, a quick repeat. Normalization is a step-by-step process of splitting single bigger table into many smaller table. We have to do this activity in the database. The reason is, if all the data is in a single table, it creates lot of performance overhead. That is the reason we break and split into many tables. If I want to give a logical scenario, as I told, in a bank, you go to the ATM. If ICICI Bank had kept all the data in a single table, to get money, it would have taken 2 hours for you guys. So normalization is a straightforward thing, breaking a single table into many smaller table without changing functionality. So we cannot simply break the table. We have to follow the normalization rule. 1NF says the table has to be single value and there should be no duplicate records. Already we splitted the name into single value and also the phone number, and duplicate was removed by breaking single table into two tables. This is 1NF. 2NF says that a relationship is said to be in 2NF, it is already in 1NF. Obviously, if you want to convert any table to 2NF, first it has to be already converted into 1NF. And non-primary key. Attribute means key, non-primary key are fully dependent on primary key. Just now we saw that. And as one of this marks table, whatever course here, the marks was not fully dependent only on the course ID, as it was partial dependency. So what we did is, we break the table and made into three table, and these two columns having primary key is called as composite primary key. Now let us jump to the third normalization form. Third normalization says that a relationship should be in second normalization. Obviously, to convert to third normalization, table you are giving to the third normalization should be in second normalization. And all other non-key attributes should be directly dependent on key attribute. This is also simple, but almost ditto of second normalization in the words, whatever it is there, but there is a huge difference in the meaning. Here also, if you see, non-key attributes should be directly dependent. In the second normalization, it is fully dependent. Okay, in the third normalization, it is directly dependent. What is this direct dependency? I will explain you with the same example. So let me come to the table in the second normalization. If you come to the student table, all the columns, name, phone number, directly dependent to the student ID. All the columns, name, phone number is directly dependent to the student ID. Let me come to the course table. Even course name, course hour is directly dependent with the course ID. Means directly with the course ID, I'll get the name. Directly with the course ID, I'll get the course hour. Let me come to the third table. With student ID and course ID together combination, I'll directly get the marks. Now tell me, with student ID and course ID, will I directly get the grades? So this is my question. With student ID plus course ID as the primary key, I got the marks. I got the marks. With student ID and course ID, will I get the grades directly? This is my question. No. Then on which column we get it directly. We get it directly. You guys can see me also. I had not shared the web screen. Okay, on which column? Oh, okay, something is written here. What is that? The one column we get it directly. Okay, all right. Let me tables. Show the tables, sir. Okay, okay. You want me to show the table? Okay, I'll show the table. Just try to which table I have to show. Third normalization, second normalization. Okay, okay. Just see this table and tell me uh, the thing on which grades is directly dependent. No. Yes. With marks. Yeah, it's correct. It is directly dependent on marks. Obviously, it's a logic. With student ID and course ID, see, if you have student ID and course ID, you will get the marks. Marks can be 80, whatever. Marks can be 80, 90, 70, 60, 40, 30, whatever it is. Based on the marks, you get the grades. If you have 80, it can be A. If you have 90, it can be A plus B. That means on marks, grades is directly dependent. However, grades is dependent on student ID and course ID indirectly, not directly. On directly, it is dependent on grades only, which should not be there. What does third normalization says? That is, all non-primary key should be directly dependent on the primary key. That means this white color, whatever you are seeing, should be directly dependent on the green color. This grade is not directly dependent on the green color. It is indirectly dependent. However, it is dependent, but not directly. On directly, it is depending on marks, which is again a non-primary key, and it is against the third normalization rule. So what we have to do is, and again we call it as in DBMS, if you guys have studied, transitive dependency should be avoided. Usually they call this word transitive, DEPENDENcy, whatever. That means A is depending on B, B should not depend on C. This should be avoided. So that is what it's happening over here. Student ID plus course ID, marks is dependent. On marks, grade is dependent, which is a transitive dependency. Third normalization says that there should be no transitive dependency, or all non-primary key should be directly dependent on primary key. However, this table is not doing that activity. So what we will do is, we'll break this table. If you see here, I have made 4 tables. One is student table, second one is course table, third one is marks table, and the fourth table is grade table. Now, okay. Now tell me, so any doubts in this? Any doubts? And 1NF, 2NF, 3NF, you can ask me. This is all about normalization. I will anyhow share this PDF document with you guys now. Have any doubt, you can ask me. 3NF, can you please repeat? Okay, alright. See here, third NF is, okay, 1 minute, let me see all the charts. Okay, 3NF, that is the thing. See, 3NF, as I told, third normalization form says that, okay, what does third normalization form says? 3NF, third normalization form says that all non-primary key should be, what is that? All non-primary keys should be directly dependent, on primary key. So let us see all these tables which is there. If you see this table, all this in the student table, all this name, phone number is directly dependent on the registration number. That means with registration number, I can directly see this name, phone number. Let me come to this course table. Course name and course hour are directly dependent on course ID. That means with course ID, I can extract course name, course hours easily. Now let me come to the one more table, grades table. Here also with student ID and course ID, I can extract the marks. That means if this registration number with course ID A3, I can tell the marks. Grades, I can extract only with the marks. Obviously, that is what I have written here. See, you have marks, you have grades. Say, how you will tell he has got A grade? How you will tell you have got B grade? How you will tell? Okay. The question is for you, Deepti. How you will tell? Depending on the marks, good. But I don't want that to happen. I want you to tell only with student ID and course ID. This is the rule of third normalization. They don't want this to happen. Third normalization directly says that all your non-primary key, marks and grades or non-primary key, should be directly dependent on primary key. That means you should add been extracted grade only by student ID and course ID. Then only third normalization is true. If you are extracting from marks, grade, that means third normalization here is not satisfying. The reason is, as I've already told, these two are non-primary key. These two non-primary key should be directly dependent on the primary key. Marks is directly dependent, but grade is indirectly dependent on student ID and course ID. It is directly dependent on grade. Marks is directly dependent on grade. That's what you told me. On the what? On 80 you might tell is mass A grade. On 70 you might tell it mass B grade. On 60 you can tell him as C grade. That means you are calculating his grade or defining his grade only by the marks. So it is not a direct dependency, it's an indirect dependency. So we cannot have indirect dependency in the third normalization. That's why I have made it as direct dependency by breaking this table again. If you see the table, now see, I've just made one table, only the marks table. There is one more table, student ID and course ID, which is again a primary key. However, I have not colored. With student ID and course ID, I can tell the marks. In this table, maybe this with marks, I am telling the grade. If you see this table, they are directly dependency. So got or still doubt? You want me to repeat again? I will do that. Okay, okay. Means okay, cool. So I want to attach this actually, this file. Okay, all right. If that is the case, I will be ending this session as of now. Thank you for joining. So let us continue this classes tomorrow. Thank you.